From an infrastructure standpoint, like at what point is, your team and all the folks in Smokejumpers, et cetera, like getting involved? What does that look like from making that scale? It's like we have the model, it's all trained and ready to go out the door, and then they just throw it to you and they're like, put this in all the data centers.
There's like an easy button. So then like you just hit it and magic happens. It's like, ta-da, it serves and it's wonderful and people love it. And
we know that's not true. Welcome back to Release Notes. My name is Logan Kilpatrick. I'm on the Google DeepMind team. Today, we're joined by Ema Taropa, who is a Google Fellow and also responsible for making Gemini accessible, all of our TPU infrastructure, serving the models, Smokejumpers, all that stuff. So Ema, thank you for coming back on, first return guest on Release Notes. How are things going in the world of making Gemini available to billions of people?
Never a dull moment. That pretty much sums it up. Still a lot of fun, a bit too much fun, and not as predictable as I would like it to be, but definitely fun. Definitely something worth learning every single day, every single hour. Best fun I've had here in the past 20 years, maybe discounting the time I was an intern.
Yeah.
But yeah, so it's a great time to be alive. And a great opportunity to work on this stuff.
When we talked last, it was, I don't remember what, it had to have been like almost a year ago when we were launching Flash, 1.5 Flash, the 8 billion parameter version. And just to like take a step back, I'm curious from your perspective and just like the story of building these massive distributed systems, serving the internet to billions of people for the whole time you've been at Google. I'm curious like how your perspective on this like story of scaling up Gemini. The goal is like as we build new models like Pro and Flash and others, they're everywhere. It's like every product service has these. It's sort of the connective tissue, which is obviously exceptionally difficult to make happen infrastructure wise. So I'm curious from your perspective how you see like how the story has changed over the last 2 years maybe.
I saw it, November or October 2022, when we're like, yeah, there's like clearly something happening in the field and we have to move very, very quickly. And let's figure out what we can put on and serve on it and how we can start, doing things like routing between different types of models, right? And how do we figure out how to allocate capacity and sort of like focus the effort and the energy expenditure in the system on one of them, to rolling that out, trusted testers, to rolling it out globally, to then starting the Gemini program, to figuring out where else in the company we had available capacity, to starting the first MOA program, to changing the paradigm and starting to doing really large models that are extremely fast and cheap to serve, along frontier models that sort of we use quite a bit. To where we are today, right? All the launches that we have in the pipeline kind of have a common thread, which is we built a lot on the base we have as a company in terms of like how do we scale systems, the same lessons that we kind of learned in the past, how to focus effort in the system, how to make things continuously cheaper and faster and scalable.
Yeah.
To sort of, the distribution we have across the array of products and services as a company, right? Which basically is what makes this place very special. And we ended up here where, we are focused extremely intentional of having the best in the class models and best in the class distributed infrastructure.
I have many, many follow-up questions. Maybe we can use 3.0 Pro as an example. From an infrastructure standpoint, like at what point is your team and all the Smokejumpers getting involved in the model training? Actually, I'm curious, like as an example, like what does that look like from making that scale? It's like we have the model, it's all trained and ready to go out the door, and then they just throw it to you and they're like, put this in all the data centers.
There's like an easy button. So then like you just hit it and magic happens. It's like, ta-da, it serves and it's wonderful and people love it. And
we know that's not true. It is. I think we have a great model, and I think that's like the start in some cases of like a lot of other hard work that folks are doing to like actually make it happen. Training the model is the hard part, which obviously is a hard part, but like actually making it available and doing all the serving work is also exceptionally difficult. So what are some of the things that go into that are challenging?
Yeah, it's a fair question. We don't operate as a disjoint set of individuals, even if we sort of end up having, maybe in my case, would be generously calling it an area of expertise. There's no such thing, but other people will be more focused on one side of the system compared to the other. But we do not sort of like make these choices and trade-offs in a vacuum. We're always like, from like pre-training side or model design side all the way to serving. We have to figure out like, how much do we want to invest in training it? How much do we want to invest in serving it? How much does it cost? How do we want to serve it? Potential customers, adoption, traffic growth, all of this, right? It all sounds very nice when I describe it like this. It's not. We get it wrong quite a few times, right? Like even now, today, we had a surprise on like, how costly is it, what we want to do next versus what we predicted, and where is the delta coming from? And because the traffic changes, the way it's used, right? Like sort of like the query volume and distribution and the usage in the applications change as the model's quality sort of like goes through these stages. So it's kind of like, a wishful thinking to have it fully mapped. Be that as it may, we try to keep sort of like some sort of semblance for like, hey, this is how we want to allocate the capacity on pre-training. This is kind of what the final product should look like. We start with something, it looks really nice. 2 weeks later, it's twice as fast. 3 weeks later, it's 4 times as fast. Ton of work from a bunch of people from, training all the way to serving to sort of dependent system side involved, right? From like load balancer to sort of like figuring out better how we can make trade-offs between what we do on short context versus long context and so on and so forth. So then, everybody gets many more generations of cute cats and stuff like that, and everybody likes it, right? We do operate as a fairly integrated team where people focus on various tasks, either for the duration of their engagement with Gemini or sort of like at various stages in it, right? So like spend a little bit of time on training, then work on serving, then work on post-training. Also keeps it fun.
Yeah.
Why Smokejumpers? Ben Trainer was running the SRE organization. And I said, look, I feel like we have to sort of have a much more nimbler sort of like team that sort of does these very, very important launches for LLM serving, that basically understands a lot about the subtleties and finer details involved in serving these things, and also has a very strong sense of ownership in like, hey, we put so much effort in this thing that sort of like we kind of own the end result.
Yeah.
So then I said, I have about 10 or 16 people in mind, and they're not necessarily on the SRE job ladder. Some were on the engineering ladder, some were like 1 or 2 on the PM ladder, and sort of others on the SRE ladder, and other on like sort of like just developing the serving system or making changes to the models, right, themselves, right? So this set of people, I said, they kind of have the type of, I guess, personality required for like doing something like this, and they might enjoy it. The sort of like common denominator here is, it's a bit of a pressure cooker. It's extremely intense, and, it attracts very similar type of engagement and personalities, and it's always fun. And then we also said, why Smokejumpers? It's a name that I guess Ben Trainer suggested, and I didn't know what it means. So I'm like, whatever, right? Like, finally it has a name. And then, Sergey is like, oh, that's a cool name. I'm like, tell me more, right? It's like, these are the firefighters that kind of like jump ahead of the flames through smoke and then from airplanes, and then they deal with it. I'm like, okay, hopefully it's not that bad. Turns out he was like actually sort of optimistic compared to what it is. And then we started another team that's called Fire Starters, which is kind of like the front end sort of equivalent of this thing. Cause like, the fire starts somewhere, and it's usually with the queries that come in, right? And, we go run together. We have what I think is not a bad esprit du corps. And we take care of serving, training. Every now and then we try to help there as well. Everything involved to making these models universally accessible and useful to our end users.
Yeah.
And we're happy most of the time. And, uncomfortably excited all of the time.
I love that. What, from that initial sort of 2.5 Pro launch, I'm curious now, as we obviously learned a bunch of the hard lessons, I'm sure, with 2.5 for 3 Pro. What's been different? Like, I think it feels like things are more organized, and hopefully they're happening, maybe not, hopefully they're happening faster, but like, I'm curious, like what if anything feels different from the Smokejumpers perspective?
Okay, so not much. Some things are better, but this is also a ridiculously good model, and it
Yeah.
got used in sort of ways that we hoped it's gonna get used, in ways that we were surprised that was used. So yeah, not entirely planned, but functional. It is just like, almost like seeing your kids grow kind of thing, right? Like, sort of like you're just happy they get this amount of usage, and it's a fun problem to crack day in and day out.
We sort of have these big inflection moments, and like 2.5 Pro is a good example of this. We find new capacity, we make all these optimizations, but it sort of like sets the new floor for like the baseline level of traffic, and then everything else that happens is just like builds on top of that. So for like 3 Flash as an example, 3 Pro is incredible, but the 2.5 models are getting used a ton still, including Flash, including the 2.5 Pro model. So where do the chips come from? How do we make it happen?
There are some degrees of freedom we have, and there's some trade-offs we make. We could do serving like this, or we can sort of trade off capacity here for latency there, and also look overall at the product, what it does, and figure out how to reduce latency and cost in the more traditional parts of the product, right? You need a lot of institutional memory, and you need a lot of knowledge about like how these things work in order to make these trade-offs. Different points in time will have different pressure points on the system overall, and sometimes you get by or squeak by with a few tricks and then pray to fix it later, right? Or as newer and newer families of models come, they kind of absorb some of the pressure that gets applied. And
The
sort of like,
developers will be in the comments and they'll say, "Don't get rid of the old models." That's what they're gonna say.
yeah, don't get it, totally fine, and we're happy you like them. And this is like, seeing your
It's a good kid. It's
your
a good problem to
grandkids
have.
basically,
Yeah,
right? So because the kids already grew and they're served, and now they have their own kids.
it is a tough balance. But hopefully we'll find the balance that makes it so we can make people happy and make a optimized serving footprint, which I feel like is those two things are a difficult trade-off. And I'm curious from the Smokejumpers perspective what you think. This trade-off between this like global optimization problem that we're doing at Google versus optimizing on an individual user basis. And the example he gave was like cache hits. Like actually this is a common thread of feedback from developers is like, why is my cache hit on Gemini lower than what I'm getting on other providers? And I'm curious if there's an interesting like infrastructure story to like answer that question of like how we're thinking about this optimization problem relative to maybe what our competitors are doing.
We just have to be competitive, right? Like there's just no free lunch, and it's just ultimately unfair to our users, right? Like how can we say use this thing if it costs you more, or it's slower, or it's not as good, right?
Yeah.
It's just a very difficult proposition to make.
What makes it difficult? This is the part this is what I want to get at. Like, I don't fully understand just the caching infrastructure in general, but like, why is that why is getting everyone globally like a higher cache hit rate more difficult?
It shouldn't be that difficult, and we can sort of replicate at the cluster level or at the global level, and we know exactly where a key is and so on and so forth. It does work extremely well for our more well-run mainline systems. We're adapting parts of it to also work very well with the slightly different structure that LLM serving requires, right? Like this, or like cache gets computed differently. The parts that we want to cache get computed differently, right? We have something that works extremely well for things like Spanner or things like web search or on and on, right? Like for the cache, it's right there. And we're trying to adapt that for LLM serving, right? The other one is, how do we route the request across our service, and how do we make sure that we make best use of the resources at the single instance and pool of machines level in order to maximize the cache rate. In Gemini app, you're going to have a different tool use, tool flow, different context, different ways of changing the context turn after turn, compared to something that's much closer to what anti-gravity does, right?
Yeah.
Right. So the usage is not the same because the product is inherently different. But, all in all, if we get very good cache rate blended, then it reduces the cost and makes it faster, and it's ultimately cheaper on everyone.
How helpful has it been to have the sort of 7th generation TPU fleet, the Ironwood TPUs? Obviously, the TPU story is something people talk about a ton externally. It's part of Sundar and others, like the full stack AI strategy that Google has obviously starts in some sense with the TPU story. I'm curious, like on the day-to-day, like how advantageous it is from a serving perspective to have TPUs. And I'm curious like how, if you spend any time, or Smokejumpers generally spends time doing this, but like we're co-developing sort of into the future and working with the teams to make sure that that happens. I'm curious if there's anything interesting there.
Amin runs what I consider to be one of the best chip program in the world, right? The only vertically integrated shop on this planet.
Yeah.
And it is nice. The same set of people, they're folks in platforms that I had the immense pleasure of working on the very first, Flash device in 2008. They worked on subsequent versions of the hardware, and a lot of them stayed with the program and sort of have also the institutional memory and the connective tissue to move very, very quickly and to know exactly who's on serving this time around, like what do they need, how do we need to change the roadmap, what sort of tweaks we have to make to this, right? It's a level of insight that I don't think anyone else in the industry has.
Yeah.
And it's ours to sort of further improve.
Talked to Sundar a few weeks ago, and one of the threads of this conversation was the MK and how it makes a company like Google, that's obviously quite large, feel actually really small. You're one of the sort of the personalities that I think brings the MK to life in a very positive way. It's an incredible vibe, people making decisions and working together and sort of collaborating. But I'm curious to just like have you touch on, I don't know if there's any interesting stories around this other than I think we talked in the last episode about bringing the espresso maker over from the old building to the new building. I think there's a new one now though.
No, it's the same thing.
It's the same thing.
Yeah, it's a three-headed La Marzocco machine. Can I say that?
Yeah.
It's like from 2008. It's great.
That's
like
crazy.
that sort of like used patina to it. Yeah, they will last hundreds of years. They make really good stuff.
I feel like the full stack AI approach, you actually see it in the MK. It's like the teams that are serving, the teams that are designing the TPUs, the teams that are making the models. There's like a bunch of interesting collaboration that I think probably comes. It's like two groups that need to make the story possible.
It's more than two groups.
Yeah, well, as an example of just like two groups.
And we have zones like that in London as well. Like
Yeah.
we have, the famous seventh collaboration space, and we did sort of the first of our like, hey, let's just bring everyone together and crack this problem. And I'm happy we do it now periodically, and we all go to a place and we focus on a problem, and it does wonders to, again, the esprit du corps that we have in this particular program, right? We had a ton of fun. We all became more than co-workers, right? They were like very good friends, and these relationships continued for like 2 decades. And a lot of those people are again in it at this point in time.
Yeah.
Right. So I do think the concept works, but I think what we have in London, what we have in New York, what we have here, this sort of like high intensity areas with a very defined operational cadence, right?
One of the interesting threads, not to put you on the spot for serving, is that why don't we have 2 million context window models anymore, Emma? I think it's partially because the models are difficult to serve, which I think is like it like takes a lot of capacity to serve the 2 million context models. But I don't know if there's like an interesting story, or if there's like, we have a path to bring that back.
It doesn't necessarily have to be a 2 million context window. Look at the Gmail launch. You can get all of your context in one place, right?
Yeah.
And I mean, like, let me tell you, that's certainly more than 2 million tokens it looks at. And there are also new hardware types that we're doing for this type of thing. But, at some point, do we serve the best in the world by a significant margin to as many users as we can reach? Or we serve, a fraction of that, maybe indistinguishable for most cases, to like like 10% of that user population. At some point we have to make these decisions, and I would like most of the people to get most of the value, if not all of it.
Yeah, the Google mandate is making it accessible to like the very large audience, and it very much is a trade-off of like, we have limited capacity and you can't serve every model in every configuration. So
again, the more useful we make this thing, the higher the sort of like utility function we provide to humanity is, right? Like, we save time at the end of the day, and then people decide where they want to spend their time. So for workspace, right? Like, I do think it matters a lot to go from like, classical retrieval systems that we have, like the token-based retrieval ones, to sort of like the embedding-based ones. Again, nothing new here compared to what we do for search. and basically sort of like using the very best in the class across all the infrastructure that we have. Because we have this type of systems, would be kind of a shame not to use them, right?
Yeah.
For embeddings, I think they have a huge potential just because kind of like, there's a different way of tackling massive, unlimited input, and sort of like getting good value out of it, right? So imagine all your context across all the properties that can be used to tailor generative AI response for what you need, right? It's absolutely critical for us to make workspace as successful as possible. And, embeddings are one of the sort of important pieces in this puzzle. So the net win there is we can sort of deploy this for more users and make it fundamentally easier for them to derive value from our products, right?
Yeah, because Google has so many interesting large scale problems, and then like product surfaces like the whole workspace suite. Like we're able to build a model that works really well for workspace, and then actually developers also benefit from it. Like we put it in the API, we now have a bunch of stuff, like tons of customers using it. It's awesome. My bet is like embedding model usage just like continues to go up. Like I think it's the other hand in hand with long context. Yeah.
Seems useful, no?
It is. It's good.
Seems useful, definitely fun. So, time well spent.
Yeah. What's the byproduct for you all, sort of like as a team of doing this 24/7 work? We were talking off camera about your bike accident and sort of like the team rallying for you personally.
The biggest satisfactions I have from this thing is the friends I made, right?
Yeah.
On a very personal level, right? And I had a bike crash because obviously I cannot go down a hill on a road bike without crashing if the turn is a bit too steep, right? Take that as you want, but that's basically the limit of my skill on a bike. And it was just a bad crash, right? But like I had a ton of luck, so I recovered pretty quickly. But be that as it may, even if I was like, functional the second day, they were like, wow, you had this very nasty bike crash, rest. Even if I was back at work the third day, kind of like working from home, because limit LCD time, who does that? Sorry, maybe my doctor doesn't look this thing. And then sort of like back in office, like, 2 weeks later, people just kick me out from the on-call rotation. On-call rotation is a little calendar that basically says like between this time and this time, if it pages, it's your job to deal with it within 5 minutes. And then they kicked me out, the week that I was supposed to be in. And then they kept kicking me out. Like at some point it became awkward, right? Because I was at work. I was like working, 24/7. Well, not really 20/7, let's say, because there's like 4 or 5 hours of sleep there. And then I said like, well, I think I'm well enough to be back in the rotation. If you want me back, I think I still qualify, right? So then they put me back, right? That's what a friend does, right?
Yeah.
And I worked with some of them for 15 years, 20 years, and it's fun. And, I'm just happy I'm in a collective like that.
Yeah.
Just on a very personal level.
One of the things that we worked on was 1.5 Flash, the 8 billion parameter version, where now we've launched 3 Flash. It's a beast model. I feel like Flash is very much punches like way above its weight class as well.
Maybe a bit too much.
Maybe a bit too much in certain contexts. But yeah, I'm curious like what your takeaway is from the launch. Like obviously a great model. Folks are super excited, which is great to see.
I mean, it's amazing we can offer that level of quality, that level of efficiency, right?
Yeah.
Like anyone can compare them, like, look at your favorite benchmark if that's what you want to do, or just like play with the thing, which is my favorite approach. Then you decide between 1.5, 8 billion parameter model and what we just launched. And, not only that, but you can look at previous generation of frontier models and compare it with this thing, and then you'll see what it is, right?
Yeah.
Was it easy? No. Is it interesting to serve? Even to this day, yes. Is it as cheap as we wanted it to be? No. But it's still an amazing model, right?
Yeah.
So the fact that we have this level of quality, relatively this accessible, is just something that makes us extremely happy.
Yeah. I feel like every time we get close to launching, or at least in the last couple of months, I'm like, I don't think we're gonna launch. We're not gonna have the chips. We're not gonna make it happen. And I feel like every time we've made it happen so
I mean,
far.
who says we had the chips? I mean, no.
Yeah, it's cool to see. Obviously, we're making AI models to benefit humanity and all that stuff, but there really is this like warmth of humanity among that you like feel among the people who are like actually doing this work day to day to make it happen.
Yeah, I mean, again, definitely up there in professional satisfaction. I would say highest professional satisfaction I had. And it's not even professional, it's just the human satisfaction. But by and large, the biggest satisfactions I have from this thing is the friends I made.
Ema, thank you for sitting down and doing this as a token of appreciation for you and actually for all the other folks in Smokejumpers. We got some nice, cool stuff made for you all. I like
Amazing. Thank you very much.
Let's check. And supposedly the thing dropping in is TPUs, I believe is what it is. So
One would hope.
one would hope. It's
Yeah, I
TPUs.
mean, one would hope, but jury's still out on that one.
Yeah.
Yeah, thank you very much. This is lovely.
Thank you for spending time. Thank you for you and all the rest of the team for all the hard work. Like it wouldn't, and Demis and Sundar and Korai and so many other folks have said this, but like it wouldn't be possible to ship Gemini across the company if it wasn't for the hard work of you and the rest of the Smokejumpers and other teams. So thank you for the hard work.
It's literally across the company effort. We're just a part of it.
Thank you for doing this. Thank you everyone for watching, and we'll see you in the next episode.